So in this segment, we still continue to look at the simple pendulum. So we still continue to look at concept under the simple pendulum. Now, if you still remember from our previous video, I did say that I will talk about factors affecting the period of a pendulum. So we can simply talk about factors affecting period of a pendulum. So what are some factors that will affect the period of a pendulum? Well, if you remember the formula that I gave you at a more advanced level, period can be given by 2 pi, then the square root of the length divided by g. So in this case, this is representing, the L is representing the length of the pendulum, and our g is representing the acceleration due to gravity. Well, it finds itself that when you look at a period of a pendulum, two things are going to be affecting it. If you look at the formula there, one of the factors affecting period of a pendulum is simply what we are calling as being the length of a pendulum. So we can simply talk about length of a pendulum. So it's one of the factors that affects the period of a pendulum, the length of a pendulum. Now, how does the length of a pendulum affect the period? Well, it indicates that the longer the string, so the longer the string, if you look at that one, you're going to find that the longer the string, the longer the period. How? Well, this is because period is directly proportional to the length. That's what you need to remember. So the period is directly proportional to the length. So this means that if you increase the length of a pendulum, it simply means that the period will also increase. So I'm indicating by the arrow going up, it indicates you increase. So if the length of the pendulum is increased, it simply means that the period will also increase. So look at these two pendulums that I do have. Look at these two pendulums that I'm actually drawing. So imagine you have got A and B. If you displace them to the same amplitude, which one will take longer to go and come back? Obviously, the longer one will take long to go and come back. And that is what we mean when the length of the pendulum is actually longer. It simply means that even the period is also going to be longer. So that's what we mean. So increasing the length increases the period of the pendulum. Now it simply means that how does this increasing the length of a pendulum affect the frequency? If you remember, I did say that frequency is actually inversely proportional to the period. Imagine if you increase the length, the period also increases. So if the period increases, inversely proportional means that if one quantity increases, the other quantity decreases in the same ratio. So if the period increases, it simply means that the frequency is actually going to decrease. So that's the relationship that you see. So remember, increasing the length increases the period. So if I take this one now, if the period increases, it simply means that the frequency will reduce. What about the opposite? Let's look at it this way. Period is directly proportional to the length. So meaning, if you make the string to be shorter, you decrease it, it simply means that the period will also decrease. But how does that affect the frequency? Well, it simply means since frequency is inversely proportional to the period, if the period in this case reduces, let me use just a blue marker so that I can assist you to see clearly. So if the period reduces, it simply means that the frequency increases. So you need to remember such relationship, because that is what they're going to be asking you in most of the questions that you're going to be finding. The other factor that I can talk about is what we are calling as being the acceleration. So we can simply talk about acceleration due to gravity. So the acceleration due to gravity, which is our small letter g. Now, how does acceleration due to gravity, affect the period of a pendulum? Well, this one entails that, the stronger, let me say just that, the stronger the gravity. So the stronger the gravity, the shorter the period. So the stronger the gravity, the shorter the period. Why? Because period is inversely, from that formula, it is inversely to the gravity. Meaning that if you were to make the gravity big, increase the gravity, it simply means that the period would reduce. So that is what you need to remember. On the other hand, because a period is inversely to the gravity, if I was to make the gravity to be very small, it simply means that you are going to increase the period. So for example, if you carry out the same experiment here on Earth our gravity is actually larger. So if you increase the gravity, the period will actually be very small. But if you had to do the same experiment on the moon where the gravity is very small, it simply means that the period would actually increase. So that is, the relationship that is extending. Of course, these are the two main factors, but when you're carrying out, an experiment in real life situation, you also need to remember that maybe I can talk about, the third factor that affects period of a pendulum. And that is what I can simply call as being air resistance. So air resistance, sometimes that air resistance, friction, because it actually creates friction or drag, as we can call it. So air resistant. So in a real life situation, you need to remember that air resistance has a slight effect in the real world, setup, because this causes, in other words, air resistance, causes, damping. So there could be damping, which is not actually accounted for. So when we talk about damping, probably some of you may be wondering, what is this damping that he's talking about? You can just say that damping is the resistance that reduces the amplitude of oscillation over time. So it will slowly, in other words, it causes the motion to slow down and eventually to stop because of air resistance. So that is why you need to remember, if there's too much wind where you're carrying out your experiment, air resistance can actually affect, your period, in this case, of the pendulum. So that is what you need to remember. Now, of course, those are factors that affect period of a pendulum. Let's talk about, factors, things that do not affect the period of a pendulum. So I can say, maybe let's say that the period of a pendulum, so we can say that the period of a pendulum is not affected by, are you thinking of things that may not affect the period of a pendulum? Of course, there are a lot of them that we can talk about. One, we can talk about the mass of the bulb. So the mass of the bulb, or others may actually say the size of the bulb. So the size of the bulb. One in the experiment may use a very big bulb, and another one in an experiment may use a very small bulb. But of course, the mass or the size of the bulb will not affect the period of a pendulum. So that is what you need to remember. So in the exam, when they talk about that, go for mass of a pendulum. It doesn't affect. To some extent, I want you just to be careful when it comes to the amplitude. So when it comes to the amplitude, if you are using a small angle, so for very small angles, maybe let me say, less or equal to 10 degrees, or maybe 15 going downward. If the amplitude is very small, then, period of a pendulum has no effect. Yeah, so if at all you are dealing with very small amplitude, then period of a pendulum has no effect. So those are concepts that you need to remember. So now, when it comes to calculating the period of a pendulum, let me take you back so that now you can actually get to understand how we can do it. So let me take you back so that you can understand how we can do it. So now let's recreate again that simple pendulum that we do have. So if you have that, let me say the rest position, it can go in that direction, it can also come in that direction. That is what you need to remember. So now this is the rest position. Now imagine you pull it and you let it go so that it starts to swing. In other words, going to and fro. It goes back and forth. That's what we mean. Let me call this one as being point A. Let me call this one as being point B. And let me call that one as being point C. So on this one, you need to know the number. You need to know the number of oscillations. So you need to know the number of oscillations, because in the exam they will not give you, but you're supposed to know the number of oscillations. So if it moves, if it moves from A to B, it can move from A to B, B to C, it comes back C to B, and it comes back from B to back to A. Now you can think of it like you have got a circle, then you divide that circle into 4 equal parts. If I shade this one, you know I've shaded 1 out of the total, which is a 4. That is what we call a quarter. If I was to include this one, I've shaded now 2, so it will be 2 out of the total, which will be 4, but that can be reduced. 2 there is 1, 2 there is a 2. If I include again this one, how many have been shaded? It will be 3 over the total, which is a 4. That's 3/4. If I was now to shade everything, it simply means there are 4 shaded out of 4, but 4 divided by 4 will give you a 1. And this concept is similar to what happens when it comes to a simple pendulum there. Let me show you how easy this is. For example, if it moves from A, if the bulb moves from A and stops at B, then how many oscillation is that? It is 1 over the total, which is 4. In other words, we say it's a quarter oscillation. That's what you need to remember. Suppose it moves from A and stops at C now. It moves from A and stops at C. Well, if it moves from A to C, that it's like it has moved 1, 2 out of the total, which is 4. So it will be 2 over 4. But remember, 2 over 4, you need to reduce that. So in other words, it is half oscillations. It has made half oscillation. If you are not comfortable, you can change this to, you can change them to a decimal number. If you are not so comfortable, you can change this to a decimal number. For example, 1 divided by 4 is simply 0.25. If you want, half is simply a 0.5. There's no problem. You can even change them to decimal values if you're not so comfortable working with fractions. If it moves from A, goes to C, then comes back to the midpoint B. It goes from A, goes to the far end C, then comes and stops at B. It simply means how many oscillations? It's like it has made 1, 2, 3 over the total, which is 4. So that is 3/4 oscillation. And if you were to work out that, if you are not comfortable with working out with that, it simply means that that is going to be 0.75 oscillation. But suppose it moves from A, goes to C, then returns back to the starting point A. How many oscillation is that? That is what we call as being 1 oscillation. So it's a 1 complete oscillation. You go from the starting point. So remember, this is more like the starting point. You go back and you come back to the same starting point. It simply means that you have made 1 oscillation. So these concepts are what you need to remember. So when you remember this, it will be easy for you now to carry out calculations. So in my next video now, I'll demonstrate to you how you can calculate the period as well as the frequency of a pendulum. Remember, just to remind you, if you remember, period is equal to the time taken divided by the number of oscillation, and the frequency can be given by the number of oscillation divided by the time. So where do you get the number of oscillation? It's this concept that I've actually told you. They'll tell you from A to B, you know, it's a quarter oscillation. If it moves from A to C, that is half oscillation. If it moves from A to C and comes back to the midpoint B, then that's a 3/4 oscillation. But if it moves from A to C and comes back to the starting point, that is 1 oscillation. So those are things that you need to remember, and I'll definitely show you how you can go about, you know, calculating the period and the frequency using a simple pendulum. I hope you enjoyed my videos. Thank you so much for watching.